Hi, and welcome to the AIX Geographic Logical Volume Mirroring Primer, where I will be describing how the AIX solution actually works and how offerings like the PowerHA SystemMirror Clustering solution can tightly integrate with it and provide a number of automated operations. Alright, so for starters, let's go ahead and take a look at a vanilla base AIX configuration where maybe I've got an OS volume and GLVM doesn't actually touch the operating system disks. But if I start adding or provisioning LUNs for my data volumes, I can take an HDisk1, maybe made up of whatever size, and start creating logical volumes in it. Now those logical volumes are going to be comprised of so many physical partitions, and then I can come in and create file systems or JFS2 mounts. So in my example, I've got a data FS1, and he's consuming partitions within that logical volume, and depending on usage, I will wind up with so much particular free space. Now, if I take the same scenario on the right and I introduce a second volume, now he may be coming from a second storage subsystem, so I can create mirroring across two different enclosures. And then as far as my logical volume is concerned, I can create all the way up to 3 copies, even though I'm only showing 2, and wind up with an LV copy 1 and an LV copy 2 sitting on 2 separate disks. Now that provides redundancy, and as far as the file system is concerned, both of my copies are being maintained on 2 separate volumes. Now when I start playing in the GLVM space, I may be using the solution when where I'm going across remote physical sites, and I may wind up with the same scenario, an LPAR on site 1 and LPAR on site 2, both with their OS volumes, so they are standalone AIX instances. And then I may have a data volume on the left-hand side and a data volume on the right-hand side. And then the key piece that GLVM actually would let me do is make that remote disk appear as if he's actually local. So I'll get a virtual representation of the volume where I'll have now an RPV, or a remote physical volume, that's mapped over the IP connection. I can just the same create a volume group, just like in the upper models, and now have my data volume group where I've got LV copies across a local disk and a remote representation of that remote disk. Now, behind the scenes, the LVM is maintaining those copies for me, and I still wind up with an LV copy 1 and an LV copy 2. And to the file system, he's none the wiser. Now, in order for me to redirect that relationship, if I wanted to flip back and forth between the two sites, I do have to maintain those RPV server and RPV client relationships. And if I use GLVM in a standalone fashion, that's an actual manual process. Now, I can go ahead and do this manually, but there are better ways to actually achieve this. Now, if I were to go ahead and redirect, I could go ahead and vary off my volume group, in essence, remove that RPV server and RPV client relationship on the bottom, or disable it, or make the disks go into a defined state, and then I'll no longer have the left hand side being the active side. Now on the right hand side, I can make sure that I've got those relationships established so I can see the HDisk1 on the left hand side now at the remote site. And if I went ahead and I imported my volume group and varied him on, I'd basically wind up with the same LV copies but now visible or accessible on the remote site. Now I did mention that I could go ahead and use GLVM in a standalone fashion, but when you kind of start looking at the bigger pie, I can see that I've got the operating system, I've got an application. GLVM is just kind of one of those components that's part of the actual operating system, but I can start leveraging tools like the PowerHA cluster software and kind of integrate everything together to provide a fully automated solution. So the deployment would still let me play in a space where I can leverage that replication in a manual fashion within on-prem servers. So I can manually flip back and forth those RPV relationships, or I can wrap the PowerHA software around it. If I build a PowerHA cluster integrated with GLVM, I can have a fully automated solution that flips back and forth. And now that's not the only way that I can deploy this. With the Power Virtual Server offering, I could have on-prem LPARs and still leverage that IP replication bidirectionally by leveraging GLVM with AIX and PowerHA wrapped around it. And then in addition to that, if I wanted to go from cloud data center to another cloud data center, being that I can't leverage block level replication in that type of solution, I can do the same thing. I can establish GLVM relationships and have PowerHA provide full automation. And if we go ahead and dive a little bit deeper and start taking a look at what a PowerHA cluster would potentially look like, I may wind up with an LPAR on the left, LPAR on the right. As long as I've got an IP connection, that IP connection is going to be used for heartbeating and then also for that GLVM mirroring. And then if you start looking at how the cluster would slice and dice those highly available resources, you're typically going to be floating IPs back and forth. So you might have service IP or IPs. GMVGs would basically be a volume group that's made up of half local and half remote disks. And then your application. So your application controller is going to manage the start and stop of your application, whether he's being hosted on the left-hand side or the right-hand side. So if you look at the PowerHA base cluster functions, he's doing all those things. He's monitoring the environment for failures, allowing the automated failover, controlling the start and stop of your application. But if we were to look at the part that we care about as far as GLVM is concerned, now we can start seeing that we have some local disks and some remote disks that comprise our data volumes. So if you look at the PowerHA GLVM functions, those RPV server and RPV client relationships, you would no longer have to manipulate those guys manually. The PowerHA software, depending on where the workload was being hosted, would automatically bring those guys online and offline as needed. Behind the scenes, he's going to ensure that those LVM mirror copies are actually kept in sync. And then in the event of a failure, so if my resource group failed over from the left side to the right hand side, he's got the ability to go ahead and do a force virion, where if he cannot have access to both sides of the disks and he can only come online with half, he'll allow you to go ahead and do a force virion. In the event that there were ever any discrepancies between the two sites, you can define a dominant site. And again, the cluster software would basically accommodate for any potential data divergence and choose which site has the latest data, and it's actually going to be the one that actually comes online. In addition to that, in the latest releases, they've introduced a number of new features, and we'll see those guys. We'll see a demonstration of that in just a minute. That allows to do a quick deploy via their new graphical user interface, and then they allow you to monitor some of the metrics and reports via that interface as well. So let me take you through a quick demonstration on if I were to go ahead and try to create a brand new cluster through the graphical user interface. So here I'm just selecting the actual host that I want to go ahead and push the config to. And as soon as I get into the screens and I start defining an actual cluster name for these particular guys, you'll see that there's an option for configuring GLVM. It'll give you some tidbits about the environment, and it'll default to a linked cluster. As soon as I select that, I can start defining things like the network name, start defining actual sites. I can define the actual cluster node members. So there's my node 1, which would be the 216 node, and then I can define a second site. You can see that I've called it something else in the past. Now I'm calling it site 1 and site 2. And then I'm defining node 2, click continue. And it'll go through and actually ask me, what repository do you want to use on site 1 and what repository disk do you want to use on site 2? And I have a very simple configuration. So I'm going to go ahead and click continue. And you'll see that it's going to ask me, what volume group do you want GLVM to go ahead and establish the replication for? If it's going to be asynchronous GLVM, what's your cache size? What do you want to use for the actual AIX LV? And if I click on continue, it's going to go ahead and create most of this stuff for me. So it's going to give me a summary of what I actually selected. And you'll see the site names, the node names, the repository disks, the size of the AIX LV. And as soon as I'm okay with this, I can go ahead and click submit. And I've sped this up, but you'll see that it's actually creating the cluster from the ground up, synchronizing it, and pushing the actual GLVM configuration. And it'll leave me with the cluster actually offline. So there's a few messages indicating that things were completed. I can go ahead and close out of those particular guys. And then if I click on the cluster itself, you'll see that it did go ahead and create the resource group automatically for me. It did synchronize things. So I'm going to go ahead and start up cluster services. And you'll see it'll take me through the same type of panels that I would if I was going through SystemMirror. But I'm going to go ahead and click continue. I wanted to go ahead and start some of those default options, and I'm going to go ahead and submit this. And again, I sped this up, but you'll see that it would go through the motions, start up both cluster members, and kind of perform the coordination behind the scenes, and leave me with the actual resource group online on one of the nodes. And now that it's actually complete, if I go to the actual GLVM tab, it's going to give me a summary of the various things that it went ahead and configured. It's also got the nice dashboard, so you'll see that it's got an option for cache utilization, for network utilization, and then also for actual disk utilization. If I'm looking at the network, those are my base IP addresses. Currently, I've got no I/O, hence why there's no cache utilization. I can select date ranges to get these metrics, and then you can see how I can take a look at the actual disk utilization. And again, I kept it super simple with a single volume on both sides. You see a number of the tunables, and the fact that it went ahead and it automatically created mirror pools for me, and it did a number of other things behind the scenes. If I want to tweak things like the AIO cache size, I can make that change dynamically. And if I want to enable some of the other options like compression or play around with some of the tunables, I can go ahead and do that from this screen as well. And if I go into one of the actual machines or LPARs that I went ahead and configured, I had indicated to go ahead and set up data VG as my actual volume group. You see that I'm doing a long listing. It automatically created those AIO cache LVs. And then there's my two volumes, HDIS2 and HDIS3. There's my listing of my mirror pools that it went ahead and automatically created. It also automatically created a resource group. There's my data VGRG with some of the policies. There's the volume group defined. There's the force option that it selected for me. And the fact that it knows that it's a volume group made up of half local and half remote disks. It also went ahead and it defined an actual application server. Now this is separate from my application itself. If I go ahead and I probe the environment, I haven't set up an actual app in this cluster yet. But if I try to get details for that application, what did it actually go ahead and configure? You'll see that it's going to go ahead and dump out some actual start and stop script logic, in that it went ahead and it created a monitor, the dashboard screen within the graphical user interface to gather metrics. This was automatically set up for you behind the scenes so that when you go to that dashboard, you can take a look at those metrics. So what I wanted to wrap up with was basically leaving you with some potential product use cases. In the on-prem space, if you provision a standby LPAR and you want to provide some form of clustering or redundancy, maybe you're playing in a space that you've only got internal disks and you can't share that storage to follow a traditional clustering model. That's where something like AIX GLVM could potentially allow you to see those second sets of disks on either side, and you could manipulate those relationships in the event that you wanted to access that data from one side or be able to flip back and forth. If you played with it in a standalone space, you wouldn't need the PowerHA software. If you wanted to fully automate those relationships and be able to move an application back and forth, again, the PowerHA Enterprise Edition could fully integrate with this type of solution. Now, more often than not, we tend to see SAN attached storage, but maybe on one of those sides, you have SAN access and SAN storage, and on the second side, you still only have internal DASD and there's no actual SAN there. AIX GLVM, as long as you're playing with volumes that are like-to-like size, can also meet that need. So that's another potential use case where you kind of have a combination of storage. And if I load up the animation on the bottom, if you have two separate SANs, so completely independent of each other, and we just get rid of the internals, you could be replicating between IBM to IBM storage or IBM to OEM storage. As long as those volumes are the same size, the way that we create the logical volume mirrors when we see that remote volume, we just care that the sizes are the same. And then likewise, I was playing in an on-prem space, but if I wanted to potentially leverage the IBM Power Virtual Server solution, I could deploy an AIX instance there and have him acting as my standby LPAR. And then behind the scenes on the Power VS space, you would have IBM SAN attached storage. They have different tiers based on the number of IOPS per gigabyte that you might actually need. And then you could establish that AIX IP replication and potentially automated with the PowerHA clustering solution wrapped around it. So there's a handful of use cases there that hopefully help to understand what the offering is kind of comprised of. If you guys have any questions, we do have a generic email address that you can send notes to, or you can reach out to myself directly. Thanks for your time.